Everything we eat, everything we touch, and everything we see is made up of matter. Our bodies are made up of matter. All living things are made up of matter. And all non-living things here on Earth are also made of matter. Just what is matter? Matter is a substance that has mass and takes up space. Matter is made up of tiny particles. What do these particles look like? How do these particles behave? What are some of the characteristics of particles found in common objects? And how are these particles classified and organized? During the next few minutes, we're going to explore these questions and others as we investigate some of the characteristics of matter and discuss how different types of matter are organized and classified. The trees in this forest are made up of tiny particles you can't see with the naked eye. The water in this lake is made up of tiny particles. And the rocks found on the slope of this mountain are also made up of particles. As you can imagine, there's a wide variety of particles. Different types of particles behave in a variety of ways. Matter is made up of different kinds of particles called elements. This copper wire, for example, is made up mostly of the element copper. And this substance is made up of the element mercury. An element is the simplest type of a pure substance which cannot chemically be changed into a simpler substance. Let's take a closer look at elements. This is a piece of aluminum flashing. It's made up mostly of the element aluminum. Aluminum flashing is commonly used on roofs to help rain and snow slide off easily. Let's cut this piece of aluminum in half, and then in half again. You decide. What's the smallest piece of aluminum that's obtainable? The smallest piece of aluminum we could obtain is an atom. An atom is the smallest possible part of an element. We cannot see the atoms in this piece of aluminum with the naked eye, but we know that all matter is made up of atoms. While an atom, such as this copper atom, is very small, it still has all the properties of the element copper. Different types of atoms from different elements have different characteristics. In nature, it's very common for atoms to combine to form molecules. The water in this stream, for example, is made up of molecules of water. A molecule of water, for instance, consists of the combination of one oxygen atom and two hydrogen atoms. For thousands of years, people have tried to understand what makes up matter. During the past several hundred years, many men and women have contributed to our understanding of atoms, the building blocks of matter. While there are many things about atoms we do not understand, we do have a good understanding of the general characteristics of atoms. Even though atoms are extremely small, in fact, millions of atoms make up the head of this pin, they're made up of even smaller particles called subatomic particles. There are three main types of subatomic particles: protons, neutrons, and electrons. Protons and neutrons are found in the inner core or nucleus of the atom. Combined, they make up 99.9% of the mass of an atom. Protons have a positive charge, while neutrons have a neutral charge. Whizzing around the nucleus are negatively charged subatomic particles called electrons, The space they occupy is referred to as the electron cloud. The electron cloud takes up the majority of the space of an atom. If we let this marble represent the nucleus of an atom, it would take up this much space in the football stadium with the electrons orbiting at the far ends of the stadium. The properties of different atoms are determined not only by the number of protons and neutrons, but by the arrangement of orbiting electrons. This car has a license plate number that is different from the license plate number of this car. No two cars have the same license plate number. Similarly, no two elements have the same atomic number. Atomic number refers to the number of protons in the nucleus of an atom. The sooty remains of burned logs are made up of a great deal of carbon. The element carbon has 6 protons and therefore has an atomic number of 6. Nitrogen, a gas that makes up about 70% of our air, has an atomic number of 7. In a couple of minutes, we'll see how atomic numbers play an important role in categorizing elements. Our bodies have mass, as do all living things. Atoms, too, have mass, but the mass of an atom is very small. As we discussed, atoms are made up of subatomic particles. Because the masses of subatomic particles are so small, scientists assign a special unit called an atomic mass unit to measure their mass. The mass of a single proton is 1 atomic mass unit, or 1 AMU. Even though neutrons are slightly more massive than protons, they too have a mass of 1 atomic mass unit. To obtain the mass of an atom, the number of protons and neutrons are added together to get the mass number. Carbon, for example, has 6 protons and 6 neutrons. You compute. What's the mass number of carbon? The mass number of carbon is 12 AMUs and is computed by adding 6 protons and 6 neutrons. Surprisingly, not all carbon atoms have the same mass. All of the atoms of the same kind of element also do not have the same mass. This is because some elements exist as isotopes. Isotopes are atoms of the same element that have differing numbers of neutrons. For example, carbon may have 6 neutrons or 8 neutrons. As a result, the atomic mass of a given element is the average of all the isotopes of that element. Since the atomic mass is a weighted average, it's not usually an even number, but instead a number with a decimal. The atomic mass for carbon, for example, is 12.011 AMUs. Imagine how hard it would be to cook dinner without knowing where the pots and pans are stored, or where food is kept, or where certain spices are located. As you can imagine, this would be a very frustrating experience. Scientists until the mid-1800s were faced with a similar frustration. This frustration was due to the lack of a systematic way of classifying the 60-some-odd elements known at the time. Many scientists tried to make some order of this chaos. The Russian chemist Dmitry Mendeleev was one such scientist. He attempted to organize elements in a systematic way. By considering the wide variety of characteristics of known elements, Mendeleev created a meaningful arrangement or table of the elements. He found that the elements could be arranged in order of increasing atomic mass. While this method was not entirely correct, it was the predecessor of the table we use today. Through the work of Henry Moseley, the atomic number, or number of protons, was determined for known elements. Today's modern periodic table is based on the periodic law, which states that the chemical and physical properties of elements are periodic functions of their atomic numbers. You may have seen the modern periodic table in a book. While at first glance it may look complicated, it contains an amazing amount of interesting information. There are over 100 known elements in the modern periodic table. When new elements are discovered, they're added. You observe. How is the periodic table divided? The table is divided into many boxes. Each box represents an element. Within each box is the complete name of the element, or just its abbreviated name, or both. Calcium, a common element in our bones, is found here on the modern periodic table and is symbolized by the capital letter C and a small a. This is called its chemical symbol. The element chlorine, often used to keep swimming pools clean, is found here with the chemical symbol Cl. While chemical symbols of elements often use the first couple of letters of an element's name, sometimes they do not. For example, iron, an element found in nails, has a chemical symbol of Fe. Notice the number 26 found above the chemical symbol. This is the atomic number, or number of protons. To the right of iron on the table is the element cobalt. It has an atomic number of 27. You decide. What's the atomic mass of cobalt? You can see that cobalt has an atomic mass of 58.93 atomic mass units, whereas iron has a lighter mass of 55.85 atomic mass units. Many big cities are designed with streets arranged in a grid-like pattern at right angles to each other. Similarly, this chessboard is arranged in a grid. The modern periodic table is also arranged in grid-like fashion. Going from left to right are rows. Starting at the left side of any row and going to the right, the atomic number increases. Notice how the atomic number increases from 5 of boron to 6 of carbon to 7 of nitrogen to 8 of oxygen, and so on. Each horizontal row is called a period. The elements in a period do not tend to have much in common with each other. The columns in the table are called groups or families. Elements within groups or families do tend to have similar properties. For example, the elements in the family labeled 11 include copper, silver, and gold, all relatively heavy metals. These are just a couple of the many patterns and relationships found in the modern periodic table. During the past few minutes, we've explored some of the characteristics of matter and the ways matter is classified. We began by discussing how matter is made up of tiny particles, and that the building blocks of matter are atoms. We took a look at elements, the simplest types of pure substances. We discussed how the modern periodic table is organized by increasing atomic number. And we explored the other types of information found in the periodic table, such as atomic mass. So, the next time you see a piece of matter, utilize an element or use the modern periodic table. Think about some of the things we've discussed during the past few minutes. You just might think about elements and the way they're classified a little differently. Fill in the correct word to complete the sentence. Good luck, and let's get started. Number 1. An is the simplest type of a pure substance. Number 2. The smallest part of an element is an. Number 3. H2O is a of water. Number 4. Atoms are made up of smaller particles. Number 5. Most of an atom's mass is in the. Number 6. The modern periodic table is organized by increasing atomic. Number 7. This chemical symbol C represents the element. Number 8. The number 58.93 AMUs represents the atomic. Number 9. The element oxygen has protons. And number 10. Elements within A tend to have similar properties.